So the bioreactor garden was really initiated by the strong need in many of the island areas where we work for low cost and effective wastewater treatment. This bioreactor garden project at Steve's was actually our first permitted and approved project, not only in Maui, but in the state of Hawaii as a whole. So it's something that we're very excited about.
The homeowner can feel good about the fact that their effluent, the water coming out of their septic tank, is being treated to a really high standard. We get really great nutrient nitrogen reduction, and nitrogen is a major pollutant if it gets into the groundwater. And so the effluent that goes into the vetiver enhanced leach field after the bioreactor garden is really clean. I think we can confidently say that nothing from this system is going down into our aquifers. And you know, the aquifer is very important in Hawaii. We want to make sure we don't want to pollute it, and this system doesn't do that. So it's a real benefit. So we're excavating a hole for three things. We've got the pump that's going to lift the water up from the bottom of the septic tank into the bioreactor garden. It's going to kind of go through this manifold that trickle down through the bioreactor garden, and then after that it's going to gravity feed into the leach field along the fence here. Now we're just digging holes. I'm here up at Steve Allen's place in Pukalani, and we're installing this bioreactor garden. And I just figured I'd show you some of the raw materials that go into, or the ingredients that go into a bioreactor. So we start out with 3/4 inch gravel. This is not very exciting, but it's just crushed basalt. So that goes in the bottom of our bioreactor. And then this material here is just a finer basalt. It's crushed kind of to almost like almost like kitty litter consistency, and we're using this in place of sand. Sand in Hawaii is a very limited resource, and so we would never want to take sand from mine sand from anywhere in Hawaii, and especially in Maui, where there's actually a sand moratorium. That's ingredient number 2. And then this pile here, it's not very glamorous looking, but this is just wood chips. So these are just tub ground wood chips from a local supplier here. Most of this is kiave. There's a little bit of monkey pod in there. In the bioreactor garden, it's built kind of like a cake. And you have one layer down at the bottom that is always saturated with water. So there's always water in it. And that's where the wood chips go. And that's where the bacteria need a place to live. And so the wood chips provide that habitat. So if you think of like a little piece of wood like this, it's submerged underwater, and all the good bacteria that are doing, they're breaking down the wastewater. They're living on this material. So that's what that's for. And then our final ingredient is this stuff over here. This is, you can kind of get a close look at it. This is biochar. It's just charcoal. You can see it's when you burn wood in a low oxygen environment, you can make charcoal, and so that's what we have here. And the purpose of the biochar in the system is again to provide that habitat for the different bacterias. Biochar is really unique in that it has a very high surface area to weight ratio. So what that means, I've read it somewhere that basically, like, I don't know, it's like a gallon of biochar has the same surface area as an entire football field. So if you imagine all the little, if you look at this stuff under a microscope, it's got all kinds of little spaces and little pore space in there. And so that, all that surface area provides habitat for that good bacteria that we want to break down the wastewater as it goes through the system. So yeah, that's our, those are our ingredients that are going into our bioreactor. Okay, so we have our outlet pipe bedded in gravel down on the bottom. That's what this riser here is, this green riser. That's the exit of the bioreactor garden. We're putting in some biochar now. That's sort of the first layer of the cake. And then we're gonna bring in some wood chips and they're gonna go in next.
Yeah, so the effluent enters the bioreactor, and once it reaches the saturation level, it spills out into an absorption trench or a leach field that's enhanced with vetiver grass. And what the vetiver grass is there for is to help dispose of any effluent that is entering the absorption trench. The roots of the vetiver grass will grow 6+ feet, and we're going to be planting the vetiver on the downslope side of the trench. So in the future, it's going to create a curtain of roots downslope of the absorption trench, and it should be really efficient at capturing any effluent that gets through that. And we're hoping to reach a pretty zero discharge type of system, so we're not allowing any of that effluent to enter the surrounding environment. Now what we're doing is digging the absorption trench, which is basically where we're going to have our outlet for our effluent coming out of the bioreactor. We're going to dig this trench. It's going to run about 60 feet. And this is basically, as effluent comes out of the bioreactor, it'll enter the trench that's filled with gravel, and we'll have vetiver planted on the downslope side of the trench that'll help capture any of that effluent that's coming out of the bioreactor garden. Good morning. So right now we've completed digging out our absorption trench, and my colleague Wes is setting up a laser level. What we're going to try to do is ensure that the bottom of this trench is all an even grade. So as the effluent comes out of the bioreactor, this outlet pipe has a slight downward pitch, but it'll enter a level perforated pipe system that'll allow the water to spread evenly along the 60-foot trench system. I think having that dead level would ensure that we have an even distribution of the effluent as it enters the absorption trench. I think once this is done, we can embed the pipe, run the system, and see how the water's flowing, and then hopefully have it all buried by today. now where I'm standing is where the perforated pipe is for this absorption trench. And with the natural grade of the land, all the effluent is flowing in this direction. So we've planted this vetiver here, and it roughly equals about 5 plants per square meter. And what this will do will produce a curtain of roots that captures that effluent before it goes anywhere. And with the water usage here at Steve's, we feel that this vetiver disposal system will pretty much take up, close to 100% of the effluent that makes it into the trench. And just based on our work in Kihei, vetiver was able to uptake about 30,000 gallons per acre per day of recycled wastewater from the Kihei wastewater plant. So in a residential setting like this, we feel that this system actually might be a little bit oversized for the volume of water coming out of this house, but it'll be a good demonstration of how we can capture all that effluent. This is the cap for the bioreactor. There's about 8 to 10 inches of soil on top of it with another topping of biochar and gravel. And we mounted it so that any water that falls on top of it would be shed off to the sides. But it's not going to be planted. It's just going to be, repopulated with the naturally surrounding grass. It's one of those things we're hoping that when we start putting in these houses, it'll be a system that's kind of out of sight, out of mind, that people won't even realize that it's there. And that's kind of the aesthetic that we're going for, especially with the nature-based solution. We're trying to blend and integrate, nature into this system so that it's really not noticeable.
Yeah, first build. It's great to get one in the ground, and you learn so much as you're doing it. It was really great to work with Steve Allen because his plumbing knowledge was really helpful, and he helped us lay out the pipes and get the right valves, and he brought that element to it, that real practical element to the sciencey side of things. And so it was a real great match, real great team effort.
The bioreactor garden itself should be good for anywhere from between 30 to 60 years. In fact, it's the leach field itself that may have a shorter time. If you talk to septic and leach field professionals, they will probably tell you that the average life of a leach field is around 15 years before that soil might get clogged with, with solids and other things, requiring it to be dug up and perhaps new pipes to be laid.
A lot of people ask about, well, wood chips, aren't they just going to break down eventually? But the cool thing is when wood is underwater, it won't break down for 100 years. So we're taking advantage of that natural process here. If a homeowner is interested in a system like this, we are approved by the Department of Health, so that's very important. There's a list of systems that are approved by the Hawaii Department of Health. This system is approved now. Homeowners can use this as an option.
The homeowner can contact us either through our contact information, which is on the Ridge to Reefs website, or we have a partner company called Nature-Based Solutions, which includes some of our other local partners that we have formed that company together. And they can reach out to us directly on the phone. And we have 2 of our members who live here in Maui. So a homeowner would essentially just reach out to any one of our staff, and we would get back to them and kind of answer any questions that they have regarding this process.
We have these 88,000 cesspools in the whole state of Hawaii that need to be replaced by 2050. And that's a real problem. That's a real liability. But I think we could really look at it like an opportunity. The rest of the country is using a standard septic tank and a leach field, and they're having problems. Those systems are failing around the country. Those systems are not treating to the level that we should be treating our wastewater to. So here in Hawaii, we have a real opportunity to kind of leapfrog over, let's do something more advanced. We can do better here in Hawaii, and we can do better than a standard septic tank and a leach field. And I think the bioreactor garden is just one, innovative solution that I think really makes sense in Hawaii. And the state of Hawaii could really lead, island nations throughout the Pacific, the mainland. We could be a real leader in treating wastewater, and it's really fitting because we're on such a small island here, and you know, we all know that everything flows into the ocean eventually, and so we know that we can do better than we're doing, and I think this is a step in the right direction.